Hi, everyone. I'm Lori DeToro, Communications Manager for Turntide Technologies. Thank you for joining us today for the Current and Wave webinar covering the benefits of a full systems approach to powertrains and how a provider with strategic partnerships helps OEMs reap these benefits. Before we get started, we have some housekeeping tips to share. This presentation is being recorded and will be available on demand on the Current and Wave website probably within about 48 hours. We will be taking questions at the end of the presentation, so please use the Q&A section, not the chat section, the Q&A section to ask your questions anytime during the webinar, and we will answer as many as possible. We also have the link for our August webinar around the safety and how to deal with the circular economy of electric motors in the chat. Go ahead and register that before you log out of the session. Remember, this is a live event, so when we mess up, and we probably will, laugh along with us and give us a little grace. That's it for housekeeping. We are ready to get started. Ryan, take it away.
Lori, thank you so much. Good morning, good day, good afternoon to everybody on the call, and thank you for joining us for this exciting session between Turntide, Rise Robotics, and EVR Motors. We're very, very excited to share some of the things that not just we've been doing in terms of collaboration and helping the broader market in that journey towards electrification, towards hybridization, towards a more sustainable future, but also share some case studies and some areas that we've actually expanded beyond this, beyond Turntide, just things we're seeing in the market. So we're very excited about it, and thank you for joining us. The folks who you'll be hearing from today, myself, Vice President of Strategic Partnerships at Turntide, Noah Croyne, Vice President of Business Development at EVR Motors, Kobe Masika, Sales Director at EVR Motors, and Kyle Delaquila, the Head of Industrial Design and Customer Experience at Rise Robotics. Not necessarily in that order, but we're really excited to be able to share some of the things that we're seeing at Turntide from a standpoint of our product offering globally, and then some of the areas that we've been actually able to, where the rubber meets the road with customers, with OEMs, partner, collaborate, and actually integrate these solutions. So, fundamentally, the challenge that we're all in, I think we all know this all too well. Basically the momentum that we've all seen, the enthusiasm that was in the market from a standpoint of electrification, more sustainable futures, things like this 3-4 years ago, it's no surprise, it has softened. Ultimately, providers, OEMs globally, we're seeing more uncertainty. We'll talk a little bit about some of the trends that we're seeing. There's obviously folks being more cautious and while maybe a little bit more protracted and a little bit slower towards adoption, definitely more targeted in the applications, in the vehicles, and in the systems that they're overall designing. I know Turntide isn't unique and others aren't unique from a standpoint of seeing projects that were supposed to kick off last year or this year that have been pushed into the future. There's obviously a number of headwinds we're seeing that we'll get into. But this is really the challenge that we've been seeing, more broadly. As we sit here in, past the middle of 2025, there's obviously a myriad of headwinds in this effort and this journey towards electrification. Certainly the geopolitical climate, we don't need to belabor the point here, but the economic headwinds and uncertainty that we've all experienced from a standpoint of tariffs, from a standpoint of the supply chain. I know that I'm not speaking alone for Turntide. The folks at EVR and at Rise have done a number of things very creatively from a standpoint of supply chain. We know we're not alone. A lot of other folks have as well, and we'll talk about some of those things. And that's even despite the subsidization programs that we've seen, emissions regulations and things that we've seen. Obviously, these have a wide variety of implications depending on the actual application, right? So Turntide and many others, we play in a lot of different verticals, right? Everything from marine, off-highway, construction, agriculture, industrial solutions, a number of different things. And obviously, depending on where you are in the world and also the application, there are performance concerns. EV technology has drastically improved, without a doubt, really in every single space. Certainly some markets are ahead of others in terms of the adoption. But usage concerns, range anxiety still exists, especially given some of those integration needs and concerns. TCO, total cost of ownership, and the ultimate return on investment will always be there. especially as we look at ways to quantify, in some cases, technology that is still being proven at scale. Many times, we see very successful initial POCs, but that question about manufacturing scalability and some things that we're trying to solve at Turntide and others to alleviate some of those concerns relative towards, okay, we understand on paper that this might make sense, but how does this translate when we go to scale, when we go overseas, when we go into the actual application? So these are all things we're continuously trying to validate and prove to the end user and to the OEM. And then lastly, gosh, we've been talking about this for many years, but on the infrastructure side, many improvements, some groundbreaking work being done then, again, depending on the application. Industrial in a manufacturing facility is very different than a mining application, right? So, what are ways that we, from a standpoint of partners and tier 1, 2, and 3 suppliers in the market, can help alleviate some of these concerns. So obviously we could spend probably the next 50 minutes on this slide, but we want to really spend a little bit of really the focus of the conversation on, yes, there has been added complexity. There have been more challenges over the last couple of years that have slowed some of this adoption towards electrification, towards hybridization. But one of the biggest challenges that we have seen, and I'm speaking for kind of the royal we here, is that there are a variety of players and suppliers that are involved in this puzzle towards this journey for electrification. There's very few that have solved it holistically. Many of us, including the folks on this call, have expertise in certain areas, in certain verticals, and in certain components. However, taking the form factor in the vehicle that was an ICE machine or ran on some other capability, and flipping that switch is obviously a drastic oversimplification. So, stepping back a little bit, and the whole purpose of the webinar, as Lori kicked off, is really, how do collaborations and partnerships, like we're going to talk about for the next 30 or 40 minutes, how can we help ease that pain and help make that a little bit simpler? One thing I love, a quote from our CEO, Steve Horniak, is, speaks towards, we're seeing OEMs no longer looking necessarily for a part, they're looking for a partner. And a partner to help that broader system integration, right? That magic black box, if you will, where if we can, flip a switch and receive that EDU, that drive unit, that entire system. Obviously, a little bit of an oversimplification, but there are certainly suppliers like Turntide that have best-in-class energy storage solutions, motors, power electronics, but those players that we think will grow the fastest and have the largest impact and, frankly, the biggest value to the customer are going to be those who build those strategic partnerships. So that's really where we want to focus today on what Turntide is calling Turntide Turnkey Solutions, but fundamentally the broader element that we're seeing with many players in the space and many suppliers as well, of basically those cases where someone like a Turntide, an EVR combine forces for the greater good of the end customer, in this case, Rise Robotics. This is nothing new. At Bauma, we heard a number of motor manufacturers, battery suppliers, gearbox manufacturers doing the exact same thing, which is really, really exciting because it's going to ultimately revolutionize and expedite this journey towards electrification. So we'll circle back on that a little bit. I wanted to kick off with just kind of a framework for the challenges that we've seen, how we're working with others, and how many others are as well beyond just Turntide. But with that, I will kick it over to Kyle, who will speak specifically about Rise's application and some of the ways that we've worked together with EVR as well. Kyle, take it away.
Cool. Thank you, Ryan. I'm Kyle Delaquila, Head of Industrial Design and Customer Experience. I'm here with EVR and Turntide to talk about a seismic shift in how heavy machineries move. We are talking about the transformation away from dirty diesel and hydraulics to direct drive, electrified, intelligent motion. And when I say electrified, it doesn't mean that we are strapped to it. We are just in it for the sport of making better machines. So it could be a hybrid machine. It might be hydrogen. Who knows what it is? But we are addressing the key problem in why heavy machinery hasn't moved to the modern era. So Rise is leading that charge, and our collaboration with EVR and Turntide has been key to that journey. Next slide, please. Thank you. Hydraulic systems dominate today's heavy machinery, but they are wasteful, dirty, and expensive. We're talking about 10%, possibly 20% of the world's diesel consumption and used on heavy machinery, and 88% of that diesel that is used is thrown away to heat because of hydraulics. And 100 million gallons of oil, of that hydraulic oil, is commonly leaked into the earth every year all around the world. As people say, if the machine ain't leaking, it ain't working. And just to put that in perspective, that's about 1/7 of all oil from all machines. 1/7 of that is from heavy machinery, is leaked into the ground every year. And just to give you another sense of perspective, 1 gallon of hydraulic oil can contaminate 1 million gallons of groundwater. So all that heavy machinery, not a lot of people aren't talking about that aspect, but that's scary if you are environmentally concerned. Next slide. Oh no. Yeah. Hydraulics weren't chosen because they were more efficient. Actually, hydraulics dominate today's heavy machinery, but they're wasteful, dirty, and expensive. And I'm, you know, I didn't want to say I messed up. I moved my notes around, but anyway,
I did say it
uh,
was a live event, Kyle, and everyone understands. It's all good.
yeah, thank you. Yeah, so essentially, hydraulics, while they are the only thing that can do the job, they are costly, hard to diagnose where the leak is. Sometimes it can happen internally, happens externally, and that's what you can see from the outside. Um, the big problem with its inefficiency is usually the control. You have to throttle, if you want precise movements, you have to throttle the excess energy back to tank. So for machines like excavators, you're often dumping 80% of that back to tank, sometimes 90. I was reading a report from Fluid Power Journal, uh, basically indicating that 20-ton excavators often are 5 to 10% efficient when you start at the fuel going in. Most of that is lost to, it's like an even split between internal combustion waste and hydraulic energy waste. So the usual alternative to um, trying to get around the fluid power stuff is to use screws. But due to the nature of screws, they can't go very fast because they resonate, they whip. Too much load, or if the screw is too long, they'll buckle, which will result in whip if you're trying to move fast. They don't like shock because of metal on metal contacts, that contact mechanic where you impact the rod. Say if you're doing a crowding motion where you're trying to jam your bucket into rocks, those shocks and impulses will impinge and they'll put dents in the screw, and then those little dents will propagate up and down the screw. They don't last very long. That's why you don't see screws inside of heavy machinery in the hard working portions of the machines. You'll usually see screws and accessories like door openers and things. So yeah, you can go to the next slide. Yeah, so hydraulics weren't chosen because they were more efficient. They won because they got the job done faster. So in this little graph here, I don't know how well the colors can jump out at people, but essentially the green line represents wire rope popularity, and the blue line represents the eventual takeover of hydraulics. And so wire ropes came before, despite being more efficient than hydraulics. Hydraulics ultimately beat it because they could get the job done faster. And then I think an interesting data point that is worth celebrating is the TX7 Bobcat screw down in the lower right corner. That's a skid steer type machine. It's more efficient. It's a bold move, but it's rare. But as you can see, you need a lot of machines to basically prove out the reliability, the performance, all that stuff in order to show the proper switch. Screws haven't really made a ding in this overall map. Next slide. All right, so we believe all that we're up to, we believe we have that better option, and we call it belt hydraulic. It's an answer to decades of compromise. It's a fast, fluid-free, and delivers hydraulic-like power without the mess. Next slide. It combines the strength of a block and tackle with the speed performance of elevator grade belts. So you couldn't put elevator belts into block and tackle configurations because belts only want to bend in one axis. Block and tackles are really cool because it's like you can, for every turn around that spiral, you can essentially create leverage, a gear ratio per se. And if you're to do that traditionally with an elevator belt, you'll just destroy it really fast. And why would you want to use an elevator belt? Well, because it allows you to have much smaller minimum bend diameters, and you can go way faster. It's very much like a car tire. So what we've done is we figured out how to combine the best of both worlds, and now you can have a complex block and tackle in a near form factor to a hydraulic cylinder. So it quacks like a duck, behaves like it, without all the problems. Next slide. So we've proven this belt hydraulic tech in the field, first with the US Air Force, where we built the world's strongest robotic arm, then commercially with our liftgate, which solves the dead battery problem, delivers smoother operation, and zero maintenance through the life of the truck trailer. That's right. You don't have to repack seals. You don't have to change the fluids. You don't have to do any of that. You shouldn't have to even re-grease the slides on the liftgate. And as time goes on with our pilot customers, we should see that it should pay itself off in about half a year. While it's not official yet, I'm of the opinion that this liftgate is the world's fastest high-capacity liftgate. Next slide. Yeah, so let's talk about speed. This is a graph of a common ball screw designed for putting out a maximum of 2 tons force. This gives you an idea of how much one should derate the speed relative to stroke length due to whip and buckling concerns. So the longer the stroke, the less speed you can give it. Ball screws should generally stay below 1 meters per second of rod speed before the little balls start pitting the races. Now roller screws is usually the better alternative, but at 2 meters per second, say at really relatively short stroke lengths to produce the same force, you'll start to have whip or resonance even at 16 inches. So that's why you don't see roller screws doing any long stroke, high force ram-like operations. Next slide. Now compare this with our 2-ton belt hydraulic cylinder. As long as you stay under 50 Newton meters of torque as defined by the working tension of the belt, and you stay below 14,500 RPM as defined by the maximum rated rotation speeds of the bearings we've sprinkled throughout the cylinder, you would effectively get 4 meters per second at 2.25 tons force, rod force. That would be about 100 horsepower of throughput. Now, you're probably saying those speeds are pretty alien, and that's why we're looking to motor companies like EVR and Turntide to see what is possible. We can add more turns in the block and tackle or not, but just with this sample cylinder we've got, this double acting, theoretically, you can do this kind of speed, which is alien. So go to the next slide, please. So this is like a side-by-side of the 2 graphs we just looked at. The belt hydraulic is the long bar. That would represent 4 meters per second on the X. And then a ball screw for that same force, obviously is not as fast. So next slide. So just for general understanding, hydraulic packings typically are rated for 1 meters per second. And if you were to go faster than that, which you could, you'd start to hurt the packings. And if you really wanted to go faster and not hurt packings, you would typically move to hydrostatic glands, but that would allow you to get up to 3 meters per second, but you will see a drop in maximum force at those speeds. Often you'd be able to do half the load at that speed, largely because of hydrodynamic losses. All the fluids trying to enter the barrel and make a right angle turn. That's, yeah, so Now when you look at Beltrolic and you're able to dispense that much power up to 4 meters per second, that's kind of alien. It really comes down to what kind of a rotary motor you can put onto it. Next slide. So to power the Beltrolic cylinder, we need a motor system that could match its performance, high torque, compact, and reliable. That's where EVR and Turntide came in. Their combined solution enabled our high-speed, high-force actuators to operate seamlessly and efficiently without a gearbox, and that was pretty big for us. I'll show you how that compares later. So that changed everything for us. Our 2-ton Valtronic cylinder was able to dispense 20 horsepower at 48 volts without a gearbox. That's fantastic. We previously were limited by the gearbox. Now we're not. We kind of opened up a whole new way of thought where we can actually start thinking about setting Guinness records on actuation because we can get around the darn gearbox. Next slide. Normally integrating a motor with an inverter is a time sink. Hopefully that video autoplays. Basically, it shows this thing moving at speed. Yeah, so normally when you get a motor and inverter, it's a huge time sink. You have to make the harnesses, you have to do the tuning, the pairing, general compatibility. It's a big problem, and I don't think it's our lack of know-how. I've been talking to other companies. Everyone suffers from this problem. When I shared this with Kobe, EVR responded by delivering a fully integrated pre-tuned EVR motor with a turn-tied inverter. Next slide. We, with their help, we had it running in days, not weeks, and we demoed it live just in time for Bauma. This is this kind of smooth integration is rare, and it's exactly why EVR built their own internal controls team and partnered with Turntide to make it easy for folks like us to evaluate how awesome their technology is. And compared to the other suppliers we were looking at, it just worked. It was quick. It was easy. It was like substitute economics. All the engineers loved it. It was honestly, I wish we knew about you guys sooner. So I'm surprised other companies don't do the same. Next slide. So the white graph with the efficiency lines, that represents our actuator in combination with the specific EVR motor we've selected. That unlocked us 2 meters per second of rod speed and about a half a meter per second at full load with this combo, and that was really huge. The black sliver you see to the very far left, that was us being limited by the gearbox. So to make this jump to us is pretty incredible, but there's still room to go. As you can see in the photo in the lower left, we can fit EVR's largest motor frame size, and I want to basically do that next on this 2-ton cylinder. That would essentially allow us to go up to 10,000 RPM, which would be 2.5 meters per second at full speed, and we'd be able to do a full load probably up to, if I'll do a wild guess, I would say 1.5 meters per second. So I'm looking forward to trying that out next. Next slide. So if all this excites you, if you want to test Beltrolic for yourself in your application, you can pre-order a sample or a developer kit to get going turnkey style in the same spirit, straight from our website. You can talk to Dan all about that. That's riserobotics.com. We're ready to support early adopters as we continue changing how machines move. Thank you. Now I will turn it over to Kobe.
Thank you, Kyle. Hello for the kind words. Hello, everyone. Ryan, thanks again for hosting us. So usually we will open with a company presentation. We'll move to it soon. We thought that it will be nice and to open with the value that we are what we are sharing. That's the fact that we are listening to our customers, we are listening to our partners. We are looking for partners that sharing the same values with us, and basically during the conversations with Kyle, we even learn more of what we need to do, and we learn things during the process together with Turntide. But the idea was to bring an optimized performance kit that will have a wide range of performance. We are doing that with kind of joint in engineering and trying to understand which product Turntides have, which product we have, how we can combine them together, how we can optimize them together. We have teams, engineering teams that collaborate and share informations and give inputs to each other. Of course, it's everything is start with technology. So we have our unique technology that which Noah will elaborate soon, and same with the technology of Turntide that enable us. It did this because without good technology, we won't be able to achieve this result and to respond fast, and really to have the time to market, as Carl described. Barma was very important to them. This was the target, and we have few months to build it and to run it and to make it perform. And this is what we are doing. This is what we are doing with this collaboration. We really trying to optimize the solution and the customer experience to our customers with our partners. So next slide, please. Yeah, so Noah, please continue. Take it from here.
Thank you, Kobe. Thanks, Ryan. Thanks, Carl, for having us here on the webinar. I'm Noah Croin. I'll give a brief introduction into EVR motors, a little bit about the technology on the product line, on the products we are able to offer, on the uniqueness of the design and flexibility, and of course about the partnership with Turntide as a part of Turnkey Solution. So basically, EVR Motors is a technology company. We have redesigned the stator shape. We've rebuilt the way that our stators and the motors are designed, structured from material perspective, from shape perspective. And the purpose was to design, manufacture, and supply motors which has superior power and torque density. But not only that, the aim is to design a motor which is also more cost effective. So lower bill of materials, we use less material to generate the same power. So amount of BOM per kilowatt is lower, dollar per kilowatt, sorry. And the manufacturing, it's more of an assembly process. So the assembly processes are also built in a way that the total capex of setting up a line is lower compared to other radial flex or axial flex technologies. And one last key important point about the technology is that we are able to easily tailor our motors for specific user requirements. I'll try to give example. I'll try to explain how we do that. But the idea is that every customer has specific needs, and we need to adjust what we are able to offer for the customer's requirements. Next slide. So really a brief overview about the technology. There is a lot to understand and learn about what we do. But if we want to understand how EVR motors are more power dense and flexible than other technologies. Basically, we're talking about 3 points behind the patent technology that we have invented. We have 17 patents, which are granted on the structure, manufacturing processes, materials which are used. But 3 main points that enables that. One is the unique shape of the stator teeth. It's what we called the trapezoidal teeth. Intentionally, we don't show it, but you have to trust my word for it. The tooth are built in a very unique shape. It's not a standard rectangular laminated tooth like we have in a lot of standard radial flux technologies. We use soft magnetic composite. This material basically enables three-dimensional shape. And we have a larger teeth, which help us generate increased flux. So overall, more flux within a given smaller compressed size of the core of the motor. And compatible to the unique shape of the teeth, we have a unique shape of the coil. So the coil is also structure in the same trapezoidal unique way. The idea is to have high fill factor, so amount of copper between the slots is between 50 to 55%. That enables, again, to generate increased flux and basically to have higher flux density in the motor. And basically the coil shape is also built in a way that enables excellent copper utilization. So all the copper is used for generating flux. We don't have end windings or copper, which is a part of the BOM you have to pay for, but it's not used for generating flux. And again, the part of flexibility of our design, which I'll explain in a few slides, is possible due to the coil unique shape and form. And the last point is unique cooling system. So both in air-cooled and in water-cooled design, we have a unique technology around superior heat dissipation. So the better you're dissipating heat out of the electrical machine, you optimize the performance out of it. That's well known. So again, higher power to rate ratio, reduced costs due to the assembly processes, and extreme and basically increased flexibility to tailor for user requirements. And next. So just an example to compare to other low voltage. This is a 48 volt comparison. Basically, the motor that you see on the right point, at the right top point of the slide, is the same motor that Kyle is using. So if you compare it to other available electric motors in the industry from well-known manufacturer, you can see that EVR is in a very competitive place in terms of power density and torque density. Even compared to some axial flux technologies. Next slide. So EVR has a line of motors basically covering up performance ranges starting from 6 kilowatt all the way up to 150 kilowatt in 4 motor families. So we basically divide the motor family by the outer diameter of the motor. So the smallest family is the 130 millimeter family, and then we have the 160. So basically the 130 and the 160 are sort of brothers or sisters. They're built the same way, just a bigger diameter, usually implemented by customer at low voltage, 48, 72, 96. For us, it doesn't matter because we have the flexible technologies around the coil winding, which I'll elaborate in a second. We have the technology in these two families are external rotors, SPM or IPM. It also depends on the user requirements and what is best for the specific application. The two larger families is 185 and the 230. These are built on the same concept of the unique stator shape that I explained, but these are internal rotor designs, and they have also the flexibility around the different lengths. So they're built in stacks. So the families are also divided into length, small, medium, long, extra long. So the customer can choose the right motor size for his application, depending on the power and torque requirements. And here we're talking about both air-cooled and water-cooled. Again, voltage is really dependent on the customer needs. I'll give an example on the 230 series. So basically, before I try to explain how we offer the flexibility that we are able to offer, I'll give an example on one of the motors from the 230 series. So the shortest 230 motor in this series was implemented one time into a light commercial vehicle, a slow speed, let's say running at rated mode at 3000 RPM because it's for the Indian roads. So it has to run at certain speeds. It has to run the certain voltage that the application requires. But on the other hand, the same design, by changing the coils and adapting it to higher speeds of operation and higher voltages, was implemented into a fast motorcycle and then used at a 400 volt system, reaching out rated speed of 6,000 RPM, maximum speed of 10 or 12,000 RPM, so a much faster motor built on the same exact mechanical design. So the investment, the engineering investment is a one-time effort on our side. And this was implemented into an Indian high-performance motorcycle, broke the Indian fastest quarter of a mile record in the continent. Next slide. So like I said, for us, we're trying to offer huge flexibility where we are players in multiple segments. So the needs for the automotive segments are different than the needs for industrial segment. What Kyle needs from his application is not at all similar for what a two-wheeler needs from application or last mile delivery vehicle or three-wheeler or anything that requires this range of powers. And the idea is to say, okay, we are able to implement we are able to easily implement changes that enables the OEM to basically not to compromise on his requirements, saying, okay, this I have an off-the-shelf offering, I'll work based on that. We're doing something else. We're saying, okay, based on the requirements of the application, the speeds that you want to work at, the efficiency zones that you require as a customer, that the application requires, the voltage, the peak power, anything that is basically a part of the SOR or the RFQ. We're trying to meet by tailoring specific items. So starting by choosing the motor length that helps define the power and torques. The coil design, the flexibility around the coil design helps us to target the right speed, the right voltage, the right peak power level. So it could be used, like I said, from multiple applications that needs and requires different working zones. A lot of adjustment around magnets and lamination, air cooled and water cooled, depending on, of course, on the application, on the system level. And in some cases, we are even doing some mechanical designs or interfaces, changes to the interfaces of the motor based on the customer projects. Next slide. So EVR's location, basically, we are our R&D center, prototype assembly lab is located in Israel. We have our own facility at Manasar, India, where we produce the coils which are part of our technology. We invested in the machinery for these coils, and we supply them for our manufacturing partner. So EVR's business model is to work with tier ones and OEM, where we license the technology. Currently, we have 3 manufacturing line, all based out of India, with 2 tier ones, Napino and RSB, which are supplying for Indian customer and European customer, East Asia and US. So basically, there are tier ones that are manufacturing the motors based on our technology, and Eka Mobility, which is an OEM that chose to manufacture the motors for his own application based on our technology. So they're manufacturing the motors for their light commercial vehicles and electric buses by themselves. Next slide. So just to sum it up and to say that we have found Turntide as a partner and as a partner that has a product line that is very much compatible with what we are trying to offer. Also, a technology which is power dense, like ours. So here you can see sort of like a high level matrix of motors and inverters which fits each other. But again, what we're doing for each customer is trying to basically find the right exact match as far as motor and controller goes, and trying, like Kyle says and Bobby said, trying to save the headache from the customer. The headache and the engineering effort that the customer has to make, and the calibration efforts of these two, and basically optimizing the performance by doing this together. I would say, before I end it, on behalf of EVR, we are honored to be a part of Turnkey Solution, and very much happy to be here as part of the webinar. I'll hand it over to Ryan to speak about Turnkey Solution and the partnership.
No, Kobe, Kyle, thank you all so much. Again, we appreciate the brief glimpse behind the curtain, if you will, of a very specific application that we were able to take months, if not years, and turn into a matter of weeks in some cases. Anytime you're doing anything with the Guinness World Records involved, it's really, really cool. So hats off to the Rise team, and a lot of this wouldn't have been possible without EVR as well. So no, we definitely appreciate the partnership. And while we dove into kind of one specific example between these three companies, between EVR, Rise, and Turntide, we're seeing this happen in a number of other applications as well. So we just wanted to kind of end and plant the seed of other areas that we're seeing, not just Turntide and Turnkey Solutions, but other companies, competitors of Turntide and others, going into this same space, which really is pretty cool. In many cases, there's elements of great collaboration even between competitors. I'll steal another word from our CEO Steve of co-opetition, where there's many cases here. I'm sure you saw on the slide. Over the last couple of months, Turntide's been very excited and very proud about our range of motors. And obviously EVR, a competitive motor player as well, and there's others that Turntide partner with as well. But in so many cases, Rise is a great example. Turntide did not have the motor for the application. However, we have a best-in-class inverter that works very, very well to complement the EVR motor. So a great look at one specific example where, sure, Turntide has a product library, EVR does as well, and Rise is I'm sure very, very similar, but there's pieces of the puzzle that together, 1 + 1 become kind of 3 in this case. So it's very exciting. A couple of the other areas that we're seeing Turnkey Solutions and other integrations happen with, and I just highlight 3 or 4 here. From a standpoint of both on and off highway, even high performance vehicle applications, more and more customers are coming to Turntide and our partners for things like an integrated EDU. So think of an automotive kit. Again, all about shrinking that time frame down from a standpoint of proof of concept all the way to SOP. Obviously oversimplifying a little bit, but an out-of-the-box kit of that EDU, right? So we have the motor, the inverter, in some cases differentials, things like that, to get as plug and play as possible, pre-tested, pre-validated to that customer's and that end user's spec for a variety of applications. So, yes, the first thing that obviously comes to mind is going to be an automotive application, but we're seeing it in construction, we're seeing it in industrial, we're seeing it in mining. Some cases we're seeing it in marine as well. So some very, very exciting applications there, from a bit of a, kind of taking the example we showed today, flipping it on its head, but no less collaboration there. A little bit simpler is expanding, and again, Turntide is not unique in doing this as well, but we are very proud of the strides we've made with EVR and with others of having prepared motor and inverter libraries. So seeing where the market is going from a standpoint of motors and inverter combinations, of current needs, of application needs, and basically saying, look, instead of kicking this off and getting time on a dyno and a test bench and going through and getting that lookup table, which many organizations and entities can do, can we get ahead of that curve? And our phone rings all the time, and I'm sure it's the same for many others out there, of saying, look, we love your motor, we love the aspects of it and the performance and what it can do in the data sheet. Who do you recommend from an inverter perspective? Who do you recommend from a motor perspective? Well, the great news is across this lineup of motors, we have this library already done. So we can ship you that motor and inverter tomorrow in some cases and have that already predefined, lookup tables done, In some cases, some minor tweaks, but basically reducing the speed to POC, eliminating in some cases the need for NRE. Obviously, always happy to support, come on site and meet customers' needs. I don't, we're not alone for that, but all about easing that integration with all of these different players involved. The third element, a little bit tied to what we're seeing with the integrated EDU, but more and more needs for gearbox integrations. Obviously, the motors can be best in class and fine, but there's many cases where there is some modification needed from a standpoint of a gearbox. So incorporating differentiators, e-lockers, different things like that. Reach out to any of us, and we can speak to that. And it doesn't stop there. Battery systems, integrating systems for rail applications, cases where maybe Turntide's battery or another partner's battery works, but we need engineering work to be associated with it. Another example of not just Turntide turnkey solutions, but what we're seeing other collaborative companies, other companies in the industry. Again, Bauma was such a great example. IVT was another. There's a number of shows coming up where I'm sure you'll see this down every hall of cases where there's very close collaboration with R&D suppliers, other tier 1 and tier 2 suppliers to help meet the OEM customer needs. So just to sprinkle a couple of other applications and areas where collaboration we're seeing win in the market, and again, not disparaging or discrediting any of the headwinds we're all facing, and our customers are facing as well. But to harken back to a point that Kobe mentioned earlier, and Noah did as well, is how can we, the industry, bring more value to the customer? And that comes obviously in terms of cost, the BOM cost. It comes in terms of speed, and ultimately the ease of integration. And that's what this is all about with Turntide Turnkey Solutions, with our collaboration with others, and with others collaborating with OEMs and tier 1 and 2 suppliers as well. So that marks the end of our prepared content. I will pass it back over to Lori for questions that have come in throughout our discussion.
Excellent. Thanks so much, Ryan. We do have some questions that have come in. So, Ryan, the first one is for you. You kind of touched on it on that last slide, but Turntide and EVR both make motors. How do you reconcile the competitive aspect of your two companies?
Sure. Yeah, a great question. And I think Noah spoke a little bit on it relative to the matrix and of performance of motors. Also, simply the fact of the technology in some cases is very, very different. Turntide, we pride ourselves on, in many cases, the axial flux motor and a bit higher power applications, and we're seeing some great adoption there. And to your point, I mentioned it a little bit on the previous slide. In many cases, our lineup of power electronics, our inverters, our new generation inverters that are coming out, complement the EVR motor very, very well, and others. There's others that are on our website that we've mentioned as well. So yes, we both make motors, but there's many folks out there that do. So we do not. I'll speak for I think both parties. We don't see each other as competitors. We see each other as close collaborators. The success we have with Rise is a great example of it. So, but a good question. I think it will be interesting to see how we continue to partner with companies like EVR and others regionally. Turntide has a global presence. EVR has a global presence. There's other companies that have very strong presence that are embedded in many OEMs in certain markets. So we're just trying to find ways to continue to augment our product offering with similar companies that run in parallel, in some cases, some competitors, if you will, but that's a bit how we view the partnership.
Okay, and by the way, just to let attendees know, you can continue to ask questions as we're answering the ones that have already come in. So if you have any questions, go ahead and put those in the question section. The next one is, are there certain components or subsystems that you see as gateway technologies for companies starting down the path to electrification? And I can open that to the panel, whoever would like to answer it.
No?
I think that the list that Kyle presented was very comprehensive, like the four hubs, VDUs, motor, inverter, battery, gearboxes. This is what we see. This is what we experience.
Okay. Anybody else have anything to add?
Yeah, I would second that. I think it's not to kind of peanut butter spread across the board, because saying something like gearbox integrations or battery systems integrations is obviously just scratching the surface. There's a myriad of specifics and details and technical assessments needed. But that's why, at least, at Turntide, we're trying to get ahead of a lot of that, whether it's with motor inverter pairing, whether it's with identifying optimal gearbox manufacturers, battery system integrators, R&D, engineering firms, just trying to, we won't be able to hit 100% of applications. Nobody will, but just trying to find ways to ease that path is kind of how we see it.
Yep. And for us, we see a requirements, again, for additional components. We specialize in motors, but what we try to do to ease up the process for our customers is to collaborate with partners like Turntide and to ease the process of integration, whether it's from an inverter or controller perspective, whether it's from a gearbox design, because we are aware of the fact that these are not isolated components and the customer basically needs a solution that supports the rest of the solutions in his system.
Fantastic. So, do you think tightening emission regulations like CARB and EU Stage 5 are pushing innovation fast enough, or is the industry still in reaction mode, such as proactive versus reactive change, and how your companies are staying ahead?
I could kind of speak to that. On we've been chatting with CARB a little bit. They're also very key in writing out the next tier emission standards, and they kind of have to look to the commercial space to see what is possible. They can't enforce something that isn't physically possible. So they can only roll out these policies based on what companies commercially, the companies already doing business, as well as companies like ourselves, small businesses, trying to highlight what can be done. And I want to say, for small businesses like ourselves, like we want them to crank up the heat. We'd also like them to say like, hey, go fluid free. Like leaking on the ground at ports is obviously like a big no-no, but like the rest of the US or wherever you're enforcing it should also be aware of the problem of contamination. But they can't roll that out unless we're already commercially in machines, or if it's some combination of their confidence in our tech. So we're over here fiercely trying to prove it out, and from a really high level, no one's going to want to integrate new technologies, whether it's just batteries or motors, into a machine if the productivity is dropped, right? Like a lot of people who have already experienced tier 4 emission diesel engines on the existing hydraulic machines are not really happy because the overall horsepower output is reduced in order to handle all that extra emissions handling. And it's people will drag their feet. And it's been a slow adoption commercially to make use of tier 4 and possibly the upcoming tier 5 if it's like incrementally cleaner for the environment but productivity drops quite a bit. That's not a good sell. So there is generally appetite to hear how those type of engines can, or if batteries can compete with them. Like can like the old John Henry story, like can the new tech, can the comparable thing to the old thing beat the competition? And that's what we have to prove. That's what we have to show. That's that's a gateway essentially. If you can show it, the floodgates open. So electrification is happening bit by bit in that regard. But I think, in my opinion, uh, there's going to be more awesome around the corner based on what I'm seeing.
Excellent. So, next question is, has anyone performed an analysis of motor RPM and efficiency at design RPM versus using gearbox reduction to obtain desired RPM cost and lifespan?
Okay. Um, I mean, I'll speak to that because like for a long time in our company's history, as we were working on different machines as well as generally actuation at large, gears were when it came down to it, when trying to commercialize any one of those technologies, gears were our enemy. I'm not even talking about screws, just like making ground toothed gears that are robust enough, bathed in oil or grease, whatever it is. It was the high cost thing. it's hard to mass produce gears, and they ultimately are mechanical choke points in the power transmission from power input to power output.
Mm-hmm.
Gear reduction is kind of necessary sometimes, and you know, you can only spin gears so fast, even with all the lubrication possible. And it's just another component to wear out and keep an eye on in maintenance. So if you're trying to replace a slew drive in a hydraulic machine with like a big gearbox, um, well, if you could do it without, the other way around is that you have to oversize the slew drive to get the job done, but then it gets expensive. So, because that's my two
I'll,
cents.
I'll add to this point that what we're doing a lot with customers is trying to balance the right zones of efficiency. So because we have a flexible technology and we can play sort of with the base speed of the motor, so eventually that caused the efficiency zones to move, let's say, right or left in the map. Okay, so we're trying to target the right efficiency, the right speeds of the highest efficiency, okay, where the application is mostly uh, throughout the drive cycles, you can see that most of the time the application run in those speeds. And what we're doing with the customer, it's really customer dependent, okay? So what we're doing with this customer is trying to find the right balance between the gear ratio he's trying to implement and the right speeds of the motors and the right efficiencies in the specific zones. So that's like a trade-off that we are doing with a lot of customers, but it's really application specifics, I would say.
Excellent. Anyone have anything else to add?
So,
And hopefully that answered the question. We have time for one more question, and this is kind of a broad industry question. So I'm going to give us time to answer it. Where are we going to see the most deployment momentum in the next 2 to 3 years? Construction, logistics, marine, recreation, military, or something else?
hmm. I'll, I'll jump in first on that one. I'm sure the rest of the group is keen to answer as well. I think looking at the landscape, and maybe Turntide is a little unique because we play in really four main verticals, right? From a standpoint of motors, energy storage with our battery business, thermals, and then power electronics. It's interesting to look at the demand and market adoption um, for each vertical by region. Certainly, motor demand in certain cases for heavier duty applications in the mining space, in some cases marine, rail, and others. It's interesting to see that demand versus say power electronics in lighter duty markets such as India, where if we look at overall demand, the axial flux technology, while we stand behind it, likely doesn't fit that automotive market as well as it does some others. So that's one element that we are looking at from a standpoint of when we go to create value for our customers and approach customers with our various lineup. And when I say our lineup, it's Turntide plus X. In some cases, it's a Turntide plus EVR, or Turntide plus somebody else. In some cases, it's our motor with someone else's inverter. In other cases, it's this exact scenario we just talked about with Rise. So I see strong tailwinds in many cases on the mining side, on the military side for obvious reasons. And then it's been interesting to see some other applications which have been traditionally dominated on the ICE side or diesel, starting to look at ways to maybe not fully electrify, but get into that hybrid zone. So we're seeing that with certain components of machines, while not fully electric, on the construction and agricultural side as well. So Kyle mentioned pump and slew drives. That's an area that we're playing with as well. So long-winded way of saying it really varies based on region and by product type for Turntide, but we are seeing it pick up, and companies and OEMs getting more creative in ways to adapt the technology.
Um,
We've got about a minute.
we've always thought it was going to be material handling because it's a low-hanging fruit. So like forklifts, very low shock, easy to pull off. But as of recently, it in terms of being able to show speed performance, maintenance, you know, uh, operating costs reduction. It seems that oil and gas has a really strong pull. It's like, oh, you have a thing. I don't care how cool the technology is, but if you can reduce the fuel consumption and make the speed go up, and every stroke has a dollar amount, here right now, please immediately. And I've never seen anything like it, and it's kind of cool. So I thought traditionally mining was the early adopter to all things new technology, whether it's making it cleaner or faster. But like, I was kind of surprised about this, oil and gas at large. It's kind of like the quiet giant that lurks in the background. And when a customer says here now, it's what a different energy.
Excellent. Kobe or Noah, do you have anything before I close this out?
No, I think we covered, and thank you very much for this session.
Excellent. Well, thank you all very much for Ryan, Noah, Kobe, and Kyle for this informative presentation. Attendees, thank you for joining us. This webinar will be available on demand in about 48 hours, and we hope you'll join us in August for our next webinar. Everybody have a great week, and thanks again.
Thank you very much.
Thank you.
Thank you all. Goodbye.
Thank you.
Thanks very much.
Thank you.